my name is Anika and I'm part of the Stat 107 team, and in this video we're going to be doing another probability question today involving gender and handedness. So let's go ahead and get started. So here I have that below is a survey results about student handedness and their gender. If we select 3 students randomly with replacement, what is the probability that not all are males? So first of all, here there's I think two important things to take into account. One thing is that we are drawing with replacement, so that means that when we select one student, we end up keeping them back in the pool. So our overall denominator, our overall pool of students that we are choosing from, this total, that is not changing. So we know that with replacement means we have a constant total. And I think the second thing to keep track of is that we are selecting 3 students and we want to find the probability that not all are male. So remember, this is not just picking one student randomly, it's actually picking 3 students randomly, and we want to find the probability that not all are male. So when I say the probability that not all are male, it means that if I pick 3 students here, I can have none of them be males. I can have 1 be male, that's fine. I can have 0 males, that's okay. I can have 1 male, that's also okay. I can have 2 males even, but I cannot, because it says not all are male, that means that I cannot have 3 males. That means that out of the 3 students I pick, not all can be males. So again, finding the probability that not all are male is the same thing as doing 1 minus the probability that all 3 students we pick are males. So I can do this question, I guess, kind of 2 ways. I can find the probability that I pick 0 males plus the probability I pick 1 male and the probability I pick 2 males, or I can do 1 minus the probability that all 3 students I pick are males. And usually this one is shorter and somewhat easier to do because you don't have that many calculations that you're dealing with here. So let's go ahead and get started. So I can do 1 minus the probability that basically all 3 students are males. So that's 1 minus the probability that, so when I have all 3 students are males, that means student 1 is male and student 2 is male and student 3 is male. So I'm going to denote student 1 as S1. So probability, and I'm going to put that in brackets, that S1 is male. And so I'm using this and symbol, and the probability that S2 is male, and the probability that student 3 is male. And I can find this by doing 1 minus, so the probability that student 1 is male, that means if I have a total of 678 students, the probability of picking a male here, I can see my marginal totals here for males. That means I have a total of 406 males out of 678 students. So the probability that student 1 is male is going to be 406 divided by 678, because I know that I'm looking at my marginal totals here. In fact, this question doesn't really have anything to do with handedness. It's just about looking at the marginal totals for the total number of males and the total number of students that we have in our pool. So that's how we got 406 divided by this 678. So that's for one student, but I will be picking 3 students randomly with replacement. So I know I need to use the multiplication rule, because remember, whenever we have and, like finding the probability that student 1 is male and that student 2 is male and student 3 is male, I want to be using my multiplication rule, because again, I'm just going to write here probability of A and B is probability of A times probability of B, and this is actually for independent events, which we know that picking students randomly with replacement is an example of an independent event because our totals stay the same. If I was picking students without replacement, that would be an example that would not be an independent event because my total number of students is constantly changing. So my denominators would be different. So here I have 406 divided by 678 times the probability that student 2 is male. That again is going to be 406 divided by 678. Because when I picked my first student, I put them back in the total pool. So that means I still have 406 males and I still have 678 total students. And the same thing for that third student I pick, that will actually be the same fraction. So this can be rewritten as 1 minus 406 divided by 678 cubed. And this exponent here, this will change based on however many students you're picking. So if I wanted to pick, maybe 100 students with replacement, that would actually be 100. If I want to pick, like 200 students with replacement, that would be 200. Because again, you're just multiplying these fractions over and over again. And here, since we have 3 students, we have these 3 fractions, so our exponent here is 3. So that really depends on the context. So when I calculate this, I get a total of 0.7852, which that is rounded. So I include these 4 significant digits here, and that will be my final answer for this question. And you can either leave that as a fraction or you can convert it into decimal. Both answers are equivalent. And just a recap of what we did here, we wanted to find 3 students randomly with replacement, the probability that not all are male. Again, not all males, meaning that I can have 0 males, 1 male, or 2 males in my selection, but I cannot have all 3 students be males. And how we figured this problem out was by using the complement rule, right? The probability that the probability of A is the same thing as 1 minus the probability of the complement of A. So the probability that not all are male is the same thing as 1 minus the probability that all 3 students are males. So that's why I did 1 minus the probability that all 3 students are males, and I just multiply those fractions, and you get 0.7852. So pretty straightforward, and that's how to do it, folks. So if you have any questions, please feel free to leave them down in the comments below, and I'll see you next time. Bye.